Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. This video shows some of the new enhancements included in VisualCAM 2016 for SolidWorks from one of our recent live webinars. Without further delay, we invite you to sit back and enjoy the demonstration.
Next, I would like to go over some of the very nice new features and enhancements that have been added to our 2016 release of VisualCAM for SolidWorks. First feature I'm going to talk about is a new method called two-axis and roughing. Now this is offered in all the configurations of our mill module. So I have a part that currently has several features that needs to be machined, and I'm starting out with a stock blank that's much larger than the part. Now in our previous versions we had to create an additional sketch geometry to define the extents of the stock and in order to program a facing operation. So what I'm going to show you here is how the system can automatically detect the extents of the stock, and what you'd be selecting is just a part boundary to program the toolpath. So I'm going to go over to two-axis and use roughing, and in this particular case use select curve edge regions to define the extents of the parts. I'm going to right click on this edge and use select loop to select the entire loop right there as the boundary and specify a tool for it, and then selecting generate, you'll notice that the system automatically determines the part extents and it knows where the stock geometry is, and it figures out a roughing toolpath. So this is a very nice way of roughing, creating roughing two-axis using two-axis roughing operations rather than having to create additional geometries for creating like a facing operation. So you can use this also to be able to program the inside features. You can go back in here and say you want to also program this pocket, so you can select the loop right around it, and if you want to specify any containments in the Z, you can use the bottom containment and say you don't want to cut below this face, and then pick generate, and there would be your pocketing operation. So you can basically go back in here, select the features that you want to cut, right click and do a select loop and specify the features to be cut, and then hit generate to program your toolpaths. So you can use a two-axis roughing technique to program it effectively. Now this feature is offered in all configurations of the mill module. Now in the pocketing operation, we made several enhancements in pocketing operation. So if you go over to two-axis and pocketing, you now have the option to specify corner cleanup loops. You can do inside and outside corner cleanup loops in pocketing. So if you want to do a corner cleanup with the inside, I'm going to go select this feature and right click the select loop to select the feature right there, and then selecting generate, you'll notice that the system creates a corner cleanup loop on the inside right there. So these are high-speed cleanup loops. Rather than just doing a linear or straight connections, you have a nice corner cleanup loop on it. If you want to switch the loop to be on the outside, you can switch the loop to outside and then generate it, and this creates an outside corner cleanup loop. Now this is offered in two-axis pocketing as well as in three-axis roughing operations. So these are some of the new features that are added in roughing and pocketing operation. Next, I would like to go over one of the new features that's offered in our profiling operation, which is basically automatically selecting the midpoint of the longest segment for programming profiles. So I'm pretty sure you remember this part we looked at earlier, and in this particular part what I'm going to demonstrate here is in our profile operation, you have an option to automatically have the system use the midpoint of the longest side to determine the location for entry and exit. So when this is selected and when we generate the toolpath, you'll notice that it automatically, the system uses the midpoint of the longest side of the geometry that you selected for the location of entry and exit. So you don't have to go and manually pick the entry and exit locations if you just want the system to automatically determine the midpoint. Also, there have been enhancements added to two-axis profiling operation where you can use mixed cuts as it alternates between levels. So you can go between climb and conventional as you step down between levels. That's one of the newer enhancements in profiling. And also in your entry and exit operation, you can also specify a angle, a ramp height. So in addition to just doing a 2D entry and exit, so the along path will basically ramp along the path of the curve. However, if you use lines and arcs and you specify a height to it, so for example, if I want to use the entry type to be linear and I will specify a height to it, you'll notice that for both the entry and exit motions, it'll do a ramp along a 3D away from the part. So you can see that in the entry and exit parameters, in addition to just doing a 2D linear, it's also doing the ramp along it. So you can use this option in here for your entry and exit in 2-axis profile operations. Now this basically showcases some of the very nice features in the new enhancements in 2-axis operations. So the next thing I'm going to go over is the enhancements that are made to the 3-axis operations in here, especially the parallel finishing and the horizontal finishing. So what I'm going to do here is go ahead and bring in a part which has a horizontal finishing operation that's already was programmed in our older versions of our mill module. So you can take a look at that. I have an operation called horizontal finishing 2015. Now you can see that with the optimized machining turned on, there were so many read tracks with the optimized machining toolpath in the older versions. Now with the new version, I'm going to make a copy of this operation, and I'm going to go back and rename it and just quickly regenerate the toolpath in here. So when I regenerate the toolpath, you will see that it'll minimize the read tracks to as minimum as possible. So it basically reduces your machining time and makes it a lot more efficient. So this is one of the newer enhancements in the 3-axis methods. You can see that it reduces the number of read tracks from what used to be when you have optimized machining turned on. Also with the 3-axis parallel finishing operation, we now added options to ignore holes on planar faces. You also have an option to machine just tops only, or tops and sides. So let's go ahead and program a parallel finishing operation for this particular part in here. And I have set the angle of cut to 45, and I've chosen tops only. You can see that only the top faces features of the part are being machined. Now if you go back and edit the parameters and change the cutting area control to top and sides, this will also be able to program both tops and sides with the parallel finishing operation. This is also one of the newer features that are available in all configurations of our mill module. Folks, one of the cool features I want to show is the automation of knowledge bases in our VisualCAM mill for SolidWorks product, and I'm going to show you how this works. And in order to demonstrate this, I'm going to go ahead and load this part in here, which basically has a pattern of holes or several hole features on it. So I'm going to go ahead and load in a knowledge base of operations that were programmed already. So I'm going to click on load a knowledge base, go to the hole features, and load this knowledge base called holes, and then click open. You'll notice that I'm being prompted with this dialog saying there were no rules set for it. So I'm going to select no, so I'm not going to set any rules when I load the files from the knowledge base. And you'll notice that in the knowledge bases tab, we now have 3 different operations in here. So we have a standard drill, we have a deep drill, and a hole profiling operation that was created in a knowledge base. Now when I expand this operation, you have an option to specify rules for the operation. So the next time I load a knowledge base on another part, it can automatically select machining geometries based on the rules that we put in. So in order to specify rules, I can double click on this and specify rules for it. Now for the standard drill operation, I would like to basically drill all the holes. So I'm going to select them as circles in here and then give it a range. So first thing is I want to drill these through holes in here and specify a range for it. So I know the holes are about 1/2 inch in diameter, so I'm going to give it a range of 0.45 to 0.6, or maybe I can put in a range of 0.4 to 0.6 right there and set the rule for the standard drill. Similarly, I'm also going to set the rules for the deep drill operation. So these holes in here are 3/8 of an inch in diameter right here. So I'm going to specify a rule for those holes as well by giving it a range for the holes. And finally, I would like to profile these counterbores, and I'm going to specify a rule for that as well by specifying a diameter range. I'm going to use 0.7 to 0.8 because those holes are about 3/4 inch in diameter. Now once I have these set, what I'm going to do here is in the feature tree, I have some sketches created on the model. I'm going to show or make those sketches visible in here. Now you'll notice that the operations have been assigned with rules. As I drag the knowledge base over to the machining browser from the operations browser, you'll notice that it automatically has selected those geometries. All I got to do is right click and regenerate, and you'll notice that the toolpaths have been computed and the geometries have been automatically identified and added to each of those operations. So when you edit the operation, you'll notice that it automatically selected all the holes of 1/2 inch in size to program the drill operation. Similarly, it has done it for the deep drill and the hole profiling operation. Now what I'm going to do here is save this out to a knowledge base with the rules on it. So I'm going to call this knowledge base automation and then hit save. The next thing I'm going to load is open up another part which has a whole bunch of these hole features in here. So I'm going to go ahead and load this part, which basically has 4 sets of the same part. Now I would like to program each of those holes. Now rather than having to program each of these holes individually, I have some sketches defined for this, which basically defines the holes for it. And I'm going to go over to the machining browser and then use this feature called load a knowledge base, and I'm going to go load the knowledge base which has the rules on it, and you'll now notice that the geometries are automatically being assigned based on the rules. So I didn't have to go through the process of selecting any of those machining features. They're automatically selected based on the rules that were put in, and you can now go ahead and run your simulation. So within just a couple of button clicks, you're able to effectively program your toolpaths by loading a knowledge base with rules. So this is one of the very nice features, powerful features, automation called knowledge base automation, which is also available in all our configurations of VisualCAM mill for SolidWorks.
We hope you enjoyed this addition to the MecSoft demonstration series. For more videos or to download and test drive any of our products, feel free to visit us online at www.mecsoft.com. Thank you.